We still have about a minute left. If you would please type in the chat box where you're located, that will help me with the presentation, since we're talking about alternative grains and different countries or different locations have different grains available. Pennsylvania, 10 baby quail right now. What kind? Bob White or Japanese? Coturnix. Coturnix. Virginia State University. First time. Okay. Glad you could join us. Okay. It's 3 o'clock on my computer. So we're going to get started. I'm hosting and giving the presentation this week. So I will try and look for chats and Q&A. Otherwise, we'll do it at the end. It's hard because I only have one screen. My name is Dr. Jacquie Jacob, and I am at the University of Kentucky. I am the poultry extension specialist here in the state, the only one. Oh, we got Burkina Faso. Okay, we do have Africa. As part of my job description, I do monthly webinars for e-extension, which is the electronic version of the National Cooperative Extension Service. And I coordinate the programs for the small and backyard flocks people. Everything is recorded and posted online. All of our past recordings are there. We have 5 years worth, so you can take a look at those. If there's something that you would like to see and it's not there, please email me and let me know what you want to hear about. So today's talk is on alternative grains for poultry production. Let's see if I can get this to work. There we are. Can everybody see my, oops. Can everybody see my slides? Of course, I can't see if you're saying yes or no. Yes, okay, good. Okay. Okay, so, why did it go? Okay, so alternative grains for poultry production. This is important for 2 different reasons. One, in the US, anyone who's growing organic or non-GMO, it's very hard to get non-GMO corn. We can get it pretty easily here in Kentucky because we use a lot of non-GMO for ethanol production for our booze. And so if you're going to organic or non-GMO, corn as the base of the diet doesn't work. Corn is the easily digested, and it is the standard by which other crops are compared. Corn is used primarily in the US, but other countries do use different grains, which may or may not be GMO, depending on what you're getting. So, oh, come on now. Okay, so when you think about trying to meet the nutritional requirements of the birds in your flocks, regardless of what type of domestic poultry, you're interested in carbohydrates, lipids, proteins, minerals, both the macro where you need lots of it and the micro where you need just a trace of it, the vitamins, and water. Never forget water. It is the forgotten nutrient. So in this presentation today, we're going to talk about carbohydrates. In next month's presentation, we will be looking at alternative protein sources. So chickens have the same types of requirements that we do, like the MyPlate that we use for human nutrition. Protein is an important part of it, but it's specifically the amino acids that make up the protein that you want, and you want certain amino acids in a certain ratio in order to have it work. So soybean meal, soybeans, field peas, canola, sunflower seeds, just some of the ones we're going to talk about next month, lots of them. The fruits and vegetables do particularly the vitamins and the trace minerals, and our dairy are usually calcium and phosphorus. So limestone and dicalcium phosphate are the main ones that we use for calcium and phosphorus. And of course, the one we're going to talk about today is the energy that comes from grains. So corn here, wheat is more Europe and parts of Canada, as is barley. Those are the, but there are more that you can use if it grows well in your area. So what are carbohydrates? Carbohydrates are molecules made up of carbon, hydrogen, and oxygen in different combinations. And so basically, one sugar molecule is a monosaccharide, two of them together is a disaccharide, and most of the plant materials that we eat have polysaccharides, which is 10 or more sugar molecules together, and the sugar provides us energy. So sometimes you'll hear of them referred to as polymers, and polymers are basically repeating units that make up carbohydrates. And polysaccharides can be either linear or branched, and that will affect the digestibility of the polysaccharide. So the main energy source that we use in cereals is starch. Starch is composed of amylose and amylopectin. The function of starch is affected by the levels of each. So amylose is easier to digest than amylopectin, and so the ratio in the particular starch in the particular cereal grain will vary, and so as well as having different branch chain lengths and how they work together. So amylose polymers have less surface area and more intermolecule hydrogen bonds to break. And when we are going through some of the different grains that we're going to talk about, I can't make a bold statement about corn or about wheat or about barley, because there are many different varieties. Different countries grow different varieties, and there are very different strains all over the place, so you can get different and every year they're making new ones, and so your state may have some crop development going on, and if you check with your local extension agent, you should be able to see what's best to grow in your area. So these are just 4 types of maize or corn standards or starches. So the highest one has 80% amylose, and the waxy has 0. So you can get anywhere in between, and that will affect the digestibility of the starch in that grain to supply energy to poultry. The other thing that is important is that enzymes produced in the body, in the intestinal system, are important for breaking down the different molecules or the different polysaccharides or whatever that your body's digesting. And enzymes function by having that molecule be engulfed or attached to the enzyme to make an enzyme substrate complex. And then when they are together, then they will break apart into their various products, which may be digested even more. But the square ones won't fit into ones that require a round one or a diamond one. So it's very specific. The enzyme is specific for the substrate, and it has to be in a particular alignment in order for the enzyme to work. So if we look at the different types of the starch versus cellulose, you can see that in starch, they have what's called an alpha 1,4 linked glucose. Okay, it's the way that the glucose is, and it's the positioning of the carbon, hydrogen, oxygen molecules. And in starch, it's alpha, which means it goes one way, and in cellulose, it's beta 1,4 linked glucose. And when you're connecting different branches, it's an alpha 1,6. So the enzymes can recognize the 1,4 and the 1,6, but they cannot recognize the beta, which is in cellulose. So poultry cannot digest cellulose. In fact, most mammals cannot. You say, well, what about the cows? Well, cows have a rumen, and it's not the cow that is digesting the cellulose. It is all the microbes that are living in that rumen that are digesting the beta 1,4 links. And so we and poultry cannot digest cellulose, but we can digest starch. And you can see it's just the way these two are aligned, and the enzyme will recognize this one, but not that one. So that's important to remember too. Carbohydrates in foods, there's many different kinds. You get simple carbohydrates, monosaccharides, which are 2 sugars, disaccharides, which are monosaccharides, which are 1 sugar, disaccharides, which are 2, and oligosaccharides, which are more than that. And then when you get very complex ones, they call them polysaccharides. And when you digest it, they become glucose units that can be digested. Some will be easier to digest than others. Then we have what's called non-starch polysaccharides, like cellulose, which we can't digest, but there are other non-cellulose, non-starch polysaccharides that occur in plants that are fed to poultry. We'll go through some of those. So non-starch polysaccharides are complex carbohydrates that are not starch or cellulose, and they are the main structural components of plant cell walls. In humans and poultry too, they contribute to the bulk of the stool, the fecal material. Some of them can be fermented in the gut. They end up resulting in short-chain fatty acids, which are important in maintaining gut health. This fermentation is usually done in the ceca, which are 2 blind pouches at the junction of the large and small intestine. They're sort of like a mini rumen. And so they can break down some of these things that cows can. But instead of being at the start of the digestive tract, it's down at the end of the digestive tract. So the short chain fatty acids do get the pH and everything right in the intestines to benefit, good bacteria and keep away bad. And these non-starch polysaccharides can affect the viscosity of the partially digested feed in the digestive tract. So that will affect digestion and nutrient absorption. Viscosity refers to how liquidy is it? Is it more like a gel, or is it, does it move really fast? That sort of thing, how thick it is. In terms of where the starches are in cereal grains, it's basically in the endosperm. It has the energy storage and protein for germination. So what we mostly talk about when we talk about starch in a grain is the endosperm. You can get some proteins in the germ. So corn gluten meal, for example, might have some of those. So as I said, corn, some refer to it as maize, is the standard to which other starches are compared. So they're easily digestible. They're the main energy source and the least expensive used in poultry diets. So it's the starch in it is the main source and form of energy. And the utilization of starch determines the energy utilization rate. So as I said, they're complex carbohydrates with carbon, hydrogen, and oxygen. So there are other cereals that can be used and are used in different parts of the world. We'll go over some of these. Cereals, by definition, are grasses that produce edible starches. Some of the ones we are going to refer to are what you call pseudo cereals. They're often referred to as cereals, but they're not grasses. So technically they are not cereals. So although the starch in corn is highly digestible, most of the other grains contain anti-nutritional factors, such as the non-starch polysaccharides, which I referred to earlier, which cannot be broken down by the digestive enzymes that poultry produce. So we're first going to go into the ones that are considered non-viscous. So the non-starch polysaccharides, or the NSPs, are soluble. So they don't usually stop in the hindgut. They get into the digestive material. In corn, which we already talked about, some of the other examples are sorghum, rice, and millet. We'll talk about the viscous cereals after that. So sorghum, the main problem with sorghum is the tannins. And I did my PhD research at the University of Nairobi in Kenya, and we worked with a lot of what's called brown sorghum. They're brown and they have tannins in them, which are an anti-nutritional factor. It's great for getting a good yield in the fields because the birds won't eat them. Birds won't eat them, and neither will poultry. So if you have high levels of tannins, which many of the native ones in Africa have, then they don't do very well in poultry diets. But in the US, they have basically eliminated tannins from the sorghums. And so virtually all the sorghums produced in the United States are white sorghums. So tannin is not an issue with the ones grown in the US. So they're also called milo in some places. They're one of the most drought tolerant cereal crops grown in some areas of the US, usually the Southeast. Their nutrient profile is like that of corn, although the energy content is slightly less. They also don't have xanthophylls, which is the pigment in yellow corn. And the xanthophylл pigments goes into the yolks and the skin of chickens to give it that yellow color. So if you're feeding sorghum, you might need, and you want, the bright yellow yolks or yellow skin, then you need to add some pigments. And in the commercial, they use marigold petals to provide that pigment. Millets, there are many, many, many different kinds of millets. Sorry, my mouth's not working today. Not all of them have been studied as a feed ingredient for poultry. The main one is pearl millet. We have studied that here in Kentucky. Until recently, pearl millet was grown in the US as a forage crop, but there are pearl millet hybrids with higher grain yields, and some of those are produced here in the United States. The millets appear to be resistant to Aspergillus favis, which is a mold, which if it grows, then the mold produces mycotoxins, which will make the bird sick. But they are susceptible from Fusarium fungi. So different types of mold it's more susceptible than others. So depending on where you're located, that could be important. Millet actually has higher protein than corn. And when we talked about amino acids being why we are adding, why we need the proteins, we need the specific amino acids. And in poultry diets that are corn, soy based, the methionine is the first limiting amino acid. Lysine is second. In pigs, it's lysine's first. There's a few others. But we just use corn and soybean meal. So if we, would switch up with some of the other cereals, which I'm going to be talking about, then we could maybe get a better overall amino acid profile for the feed that we are giving to the chickens. Pearl millet has less anti-nutritional factors than other alternative, that should be grains, not grins. Compared to rye, they are low in tannins, does not need to be heat treated to destroy any protease inhibitors. That's another one of those anti-nutritional factors. But it does contain saponins, which are known to damage the lining of the digestive tract. So you have to be careful how you use pearl millet. Research shows that you can do up to 50% of a diet for meat chickens can be pearl millet. For laying hens, you can put quite a bit in, but without any effect on egg production or fetus efficiency, as long as the pearl millet is ground. Or perhaps with you giving grits. So the gizzard may have trouble grinding it up. But the other thing is that pearl millet has a fatty acid profile that is high in omega-3s and low in omega-6s. And so they give a better profile for eggs, and you get more money for those eggs if you are able to increase the omega-3s and decrease the omega-6s. Rice is used in some places, especially Asia. Then there's brown versus white rice. In Asia, brown rice is an inexpensive and, of course, local because they grow it there, feed source with high nutrient availability. They have high energy value and low fiber content and is balanced in the essential amino acids. And of course, the presence of other non-starch polysaccharides, the NSPs, is low, so you don't have as much problems with that. But it's brown versus white. So in the US, where we do grow some or process some rice, the hard outer layer of rice grains has to be removed, or to make white rice, it has to be removed during the processing of brown rice. So rice bran is often available as a byproduct of the rice industry, and we do have some of that here in the US. It is high in fiber, which limits its use to a maximum of 10 to 20% of meat chicken diets. We also talked about the unsaturated fatty acids, and so rice bran has a propensity to become rancid. Whoops. Go back. Where are we? Oh, we got to wheat. It also contains phytate or phytic acid, which binds phosphorus and other minerals, making them unavailable during digestion. And so for phosphorus, most cereals have phytate, which binds especially phosphorus. And so with a lot of the animal diets, especially with large concentrations of animals, phosphorus is added as dicalcium or monocalcium phosphorus, and that is the available phosphorus. Anything that's contained in the phytate is not available. So if you're looking through the mineral content or the nutrient content of cereals, you'll see non-phytate phosphorus, which is that inorganic material that you're adding. You can add phytase, which is an enzyme that can digest phytate to make it more available. The rice bran also contains an enzyme inhibitor, trypsin inhibitor. Trypsin is involved in protein digestion. Rice bran is rich in protein and fat, and it does contain high levels of the B vitamins, vitamin E, and some of the trace minerals. Rice bran is sometimes used in layer diets just to filler to try and dilute the energy. So we went over some of the non-viscous cereals with the corn, sorghum, rice, and millet. Now we're going to go over some of the viscous cereals because they are high in soluble non-starch polysaccharides and cause problems. So while there are alternatives, they all have their different quirks with how you can use them. So wheat, first one, it's more commonly used in Western Canada and Europe because that's what they can grow. Again, it doesn't have the xanthophylls that yellow corn has. So if you want the yellow yolks and the yellow skin, then you have to add some pigments like the marigold petals, which contain the xanthophylls. And a lot of times you see these reports that say Americans prefer yellow skin chickens, yellow in their yolks, whereas Europe prefers the white skin chickens and the much more paler yolks in their eggs. But I think it's more, not necessarily cause and effect. That is what they use. And so that's what their consumers are used to. So if you're used to eating bright yellow eggs, then that's what you're going to want. If you're used to doing the pale ones with the wheat, then that's what you want. So it's more what people are used to rather than, Americans wanting one thing and Europeans wanting something else. Wheat varieties can be classified as soft or hard depending on their gluten content. Hard wheats tend to have a high protein content, while soft wheat varieties have a high starch content. Durum wheat, which is mainly used for human consumption, is the hardest of the wheat varieties. Wheat types are also classified as red or white, depending on the color of the grain. And a third classification reflects the variety's growing season. So winter wheat is planted in the fall, becomes dormant to tolerate winter temperatures until spring when it germinates. Spring wheat lacks that dormancy capability and can only be planted in the spring. So there's lots of different types of varieties to choose from. Most of the varieties are described as how they work in baking. So, different types of wheats work better in cookies or pasta or cake or whatever. So the bakeries really need to know a lot about wheat. So you can see here some of the different colors. The wheat varieties that are usually used for animal feeds depend on the location. So we said wheat is used in Western Canada and Europe, but in North America, which includes Canada, hard red spring or winter wheats are generally used, while in Europe, soft wheats are more common. So typically when you are looking for a wheat to put into your diets, you're looking for hard red. Different varieties of wheat contain different types of starches with different levels of the amylose and the amylopectin. Some of them are harder to digest than the corn. And again, if it goes all the way through to the hindgut where the ceca are, these starches become food sources for the bacteria that live down there and may form waxy particles and lead to sticky fecal material. So the digestives become more viscous, and so it doesn't flow as nicely. It also holds some of those released nutrients so that they can't be absorbed for that. And use of supplemental feed enzymes helps alleviate this problem, breaks down some of those non-starch polysaccharides. I mean, the different types of starches. I remember when I was an undergraduate student, we did some research at the one of the research facilities, and they knew that you had to add a feed enzyme to some types of wheats. Some you didn't have to, it was a waste of time, and some you did. So it very much depends on the variety of wheat. So they did a lot of testing on what type of variety needed enzymes and which ones didn't. And a lot of that is how their starch works. Recently, there's been interest in feeding whole grains to poultry. Some experts believe feeding whole wheat or feeds with whole wheat to chickens improves their digestive tracts. It increases the bird's ability to resist coccidiosis challenge. So if that's an issue, that might help you. And including a higher percentage of ground wheat in feed can result in flour buildup in the feeders. So you have to make sure that you take extra care to not leave a lot of that flour at the bottom of the feeders at the end of the day so that you don't have mold growing there. The husk of wheat detaches from the grain when it's being harvested or threshing. In conventional barley and oats, which we'll talk about shortly, the husk remains attached. So since wheat loses that husk as it's harvested, it has lower fiber content than barley and oats. The energy content of wheat is 94 to 96% of that of corn. Wheat is higher in protein and the amino acids lysine and tryptophan than corn, so they can balance each other off. And it's usually, you can usually, depending on the variety, you can usually substitute corn with sorghum, millet, or wheat, depending on what variety you have and how digestible it is. So wheat provides about 5 to 10% less metabolizable energy than corn, and that metabolizable energy is a measure of how much is available to them. There's a gross energy, which is, you burn it and see how much energy it gives off, but metabolizable energy means that they are able to digest and metabolize the things to get energy. And as I said, they were trying to figure out what was the problem with different types of wheat that you needed the enzyme or you didn't need the enzyme. And this was due to the presence of soluble non-starch polysaccharides, which, as I said before, they increase the viscosity of the material in the digestive tract as it goes down, reducing nutrient digestibility. So you're not getting all the amino acids that are there. as well as the glucose from the breakdown of starch. Spelt is, I've seen some people use it. It's not as well known anymore. They're considered an ancient wheat species, but they show higher resistance to environmental influences than common wheat. So some areas where they can't grow common wheat, they will grow spelt. It does not require intensive cultivation, pesticide application, or fertilizer. So it's more environmentally friendly. It's grown on a limited scale as fall sown crop in Western Europe, and it has been studied as a potential crop for Western Canada. The nutrient levels, as well as the anti-nutritional factors in spelt wheat, are similar to those of conventional wheat. Retention of the hulls on the grain at harvest has limited the use of spelt. So we said when you harvest conventional wheat, the husk falls off, but with spelt wheat, it stays on. There's very little research, but very little current research, but early studies indicate spelt could replace corn in chick and poultry diets with no significant differences in growth, but it does reduce feed efficiency. It's going to cost you more feed in order to get the same body weights. But they've shown that the addition of fat to the diet improved the feed conversion, suggesting that the research that they published where they saw reduced feed efficiency if corn was replaced with spelt was probably because the energy value that they were assigning to spelt in their diet formulations was higher than what was actually available to it. So if you use the correct energy content, you probably could use it. Barley, another one that Canada and Europe use. There's with and without hulls. So the hulls have most of the fiber that you have to watch out for. So barley is commonly used in poultry diets, as I said, in some regions of Canada and Europe. They're grown on areas of both irrigated and dry land in the USA. It's an early maturing crop that fits well into crop rotations as a pasture crop. It breaks the disease, insect, and weed cycles of some of the other crops, but it has a lower energy. It has low starch content, high fiber content, and some anti-nutritional factors. But for some of the organic growers, it may fit into their rotations to help with the control of the things that we would normally use pesticides for. And so there may be a role for barley in some of the organic farms. And although barley is commonly grown for malting, it can also be grown for human food and animal food. Barley's carbohydrates are not as easily digested as those of corn. First, it was thought to be because of high fiber content, but hull-less barley cultivars show similar performance, so it's not because of the hulls. It's because they contain beta-glucans. Because of the structure of the beta-glucan molecules, they cannot be easily digested by poultry. It binds water in the intestines as it's going through the digestive tract, resulting in gel formation and thus increasing the viscosity of the intestinal content. And again, as we did with the other one, with wheat, it reduces the availability of the nutrients in the diet, and you can see an increased incidence of tasty buds. You also get sticky droppings, which can cause water buildup in your litter. They also have phytate or phytic acid as a problem, binding that phosphorus, so it's not available to the animals. They're constantly developing new varieties of barley, and they have some that are low in phytic acid or phytate that you can get. For the ones that are not low in phytate, you can use enzymes to improve the phytate-bound phosphorus availability. That enzyme is referred to as phytase. This is commonly added to most commercial poultry diets because cereals are high in phytate. So to release that phosphorus, they add phytase. This is especially important in Europe, where they have a high concentration of manure, and they are trying to reduce or eliminate the environmental contamination potential of poultry manure. If you don't add phytase, then all that phytate-bound phosphorus goes straight through and comes out in the poop and can cause contamination in waterways, and you get, algae blooms and all sorts of things. So adding the enzymes, it releases that phosphorus, so you don't have to add as much of the inorganic phosphorus, and so there's less coming out the end. Feeding unground whole grains of barley has become more popular in some to reduce the feed handling costs, so you don't have to actually grind it. They've shown that feeding 20% whole barley to turkeys has no negative effects on growth rates. Feeding a diet with 35% or more whole barley initially reduced growth and feed efficiency, but it did result in reduced mortality and reduced leg problems. So, you have to do the cost benefit ratios. If the barley is cheaper than the corn, you might get, it might take longer and more feed to get it, but you'll have less mortality and less leg problems. So you have to look at that when you're trying to formulate your diets. And feeding that should be grit, not grits, is not necessary when feeding whole barley to turkeys. They're able to break it down themselves without having to add grit, which would go into the gizzard to help digest the whole barley. Feeding whole grains to laying hens was shown to reduce egg production, feed efficiency, and shell quality, while increasing feed intake, egg weight, and body weight. So feeding whole grains to laying hens might not be a good idea, but there is a role for it in meat turkeys and probably in meat chickens. Rye is a versatile crop. It can be grown for forage for ruminants and as a green manure in crop rotations, not rations, as part of an organic farm. It's used for human consumption. You get rye bread, or a lot of people like rye bread. Alcohol, distillation, and as a feed ingredient on its own. It does cross-pollinate. While wheat and barley are self-pollinators, that because it cross-pollinates, it makes it very difficult to have pure lines that they do for breeding different varieties of the rye, and there are winter and spring ryes. The nutrient content of rye grains is similar to that in wheat and corn. So if you just did, a laboratory analysis, it would mislead you because the nutritive value of that rye grain for poultry is very poor. Growing poultry showed depressed growth performance, and when used in turkey and meat chicken diets, again, it results in that sticky droppings that add moisture to the litter. Moisture in litter can cause the breakdown of manure, and you get ammonia, which can be a problem. More moisture in the litter can also exacerbate coccidiosis. Again, you get that increased incidence of pasty butt. So they contain highly viscous non-starch polysaccharides, and the particular ones are pentosands and arabinoxylans, which are parts of the crop plant. Rye can be fed to laying hens, but it should be introduced only after the hens have reached egg production, which is about 40 weeks of age, depending on the breed you're using. A maximum of 40% inclusion, since again, you get that sticky droppings. And if you're, it's egg production, so having that sticky droppings can result in stained eggs, which if you're selling commercially, you would not be able to do. Although there are commercial enzymes available that can counteract the negative effects of rye, the primary concern is the presence of ergot alkaloids. Ergot, which is a fungus, is the most common disease of rye. It can be very toxic if present in sufficient concentrations. It's less of a problem in some of the newer cultivars, which have been bred to be resistant to the fungus. And you can also reduce the risk if you're using the ones that aren't that, by controlling weed grasses around field borders to reduce the chance of ergot growing. Oats. Oats are grown primarily in cool, wet regions of the world. The nutrient composition varies widely depending on the variety, the climate, and the fertilizer practices used. The hull content of a whole grain of oats can vary from 20 to 50%. And of course, the higher the fiber, higher the hull, higher the fiber content, the less you can use it. The amino acid profile of the protein that's present in oats have higher levels of lysine, methionine, and cysteine than other cereals. So again, I propose that we stop using, for organic poultry diets that don't want to use synthetic methionine, they need to start looking at combinations of different cereals or other energy sources to balance those amino acids without the use of synthetics, which organics do not want. They use them in a limited rate right now, but oops, what happened? Okay, in the past, oats were used sparingly because of the high fiber content and because oats contain beta-glucans, which are anti-nutritional factors that interfere with the digestibility of the feed consumed. But, the availability of commercial enzymes that compensate for those anti-nutritional factors have increased interest in oats more recently. Whole oats have, as I said, have a high fiber content, so they're not really good for growing meat poultry like chickens and turkeys, but they can be used in older puller grower diets, pullet developer right before they start to lay eggs, and the breeder diets when they are already laying. Let's see how I'm doing for time. I better hurry up. Oats are higher in oil than other cereals, and the oil is rich in unsaturated fatty acids, especially the essential fatty acid, linoleic acid, which is important in egg production. Feeding poultry diets composed of more than 25% oats is reported to cause off flavors in chicken meat. Oat hulls, so if they remove the hulls and don't include that when they're feeding the oat grains, the oat hulls have been studied for inclusion in diets for replacement pullets. Those are the ones you're growing up to become laying hens. They've shown that oat hulls reduce mortality and cannibalism and make the birds more resistant to the effects of environmental heat. Feather pecking is a common problem in non-caged egg production systems, but the addition of about 3% oat hulls during the rearing period has shown to reduce feather pecking without the need for beak trimming. So but the inclusion of small amounts of oat hulls does negatively impact pellet quality. A lot of laying hens are fed a mash and not pelleted diets, but if you want to pellet it, you're going to have trouble with the oat hulls. Now there's a new variety out. This is totally different from oats. These are called naked oats. So oats or oat groats are whole oats that have had the hull removed through mechanical means. So that's where we separated the oat hulls. Naked oats or hullless oats lose their hulls during the harvesting process. So you don't have to do anything to them. Once you harvest them, then the hulls are gone. Because they have no hulls, naked oats are lower in fiber than regular oats, but they do still contain the same beta-glucans as whole oats. Naked oats have a higher protein, fat, and energy content than the regular oats. Some Canadian research indicates that naked oats can compose up to 60% of the diet of laying hens, replacing some of the corn, soybean meal, and oil with no loss in production, but there is reduced feed efficiency. 30% naked oats had no negative effect on feed efficiency. Triticale is a new cereal that's been developed. It's a hybrid developed by crossing wheat and rye to produce a grain with the feeding value of wheat and the drought and disease resistance of rye. It is reported to grow well in regions not suitable for corn and wheat. In Canada, areas where they can't grow corn or wheat, they may grow triticale. And in Ontario, Canada, triticale is grown as a means of a crop rotation and soil conservation. It has more protein, especially lysine, than wheat. As with wheat, triticale contains the anti-nutritional factors of arabinoxyline, one of those non-starch polysaccharides. Its potential is improved by using feed enzymes that specifically break down the arabinoxylans. Approximately 35% of Canadian ethanol production is wheat-based, but triticale is reported to have equal value to wheat grain for ethanol production. Triticale has less environmental impact than wheat because it has comparatively higher yields with reduced crop inputs, and the dried distillers grains with solubles that are left as a byproduct of ethanol production from triticale can also be used in meat chicken diets up to 10% with no adverse effects on production. Just like we use corn, dried distillers grains with solubles, you can do it with triticale as well. Buckwheat is not, it's sometimes grouped with the grains, but it's not a true grain because it's not a grass. So they call it a pseudo grain. It does have favorable agronomic characteristics, which make it, for some areas, be the perfect crop. It often yields a better crop in poor soils than the true soils. It can be included in an organic crop rotation to disrupt, that should be weed cycle. Can be double cropped with wheat to use the land. And it's a popular crop with beekeepers because of the resulting honey has a very distinctive flavor that many people like. The amino acid composition appears to be nutritionally superior than that of cereal grains, high in lysine, which most cereals are low in, along with the methionine, which can compensate for the lower lysine levels in regular cereals, which we already talked about. This has not translated into good performance because of the anti-nutritional factors present. So it has protease inhibitors. Those are ones that protease digests protein. So if you can't digest your protein, then you have a problem. And it does have some tannin levels, but they are always working at developing new varieties, and I'm sure they're going to breed out some of that tannin. Although up to 60% buckwheat can be included in meat chicken diets with no impact on overall body weight, there is that reduction in feed efficiency. So again, you need to look at the cost benefits. If it's cheaper than corn, maybe you want to do that so that you get the reduced feed efficiency, but it's more profitable. The diets of animals raised outdoors should not include high levels of buckwheat. Buckwheat contains phagopyrin, which is a substance that increases skin sensitivity to UV light, and so you can get sunburns, and that includes the chickens. I remember when I was working in Minnesota, the Buckwheat Growers Association was looking at increasing buckwheat use, and they did have a flock that put too much buckwheat in their diets, and the chickens all went to the processing plant with sunburns and all had to be discarded. But those raised outdoors should have no more than 30%, and depending on where you are, you might even want to do less than that. Amaranth is an ancient crop cultivated for grain for thousands of years. It was a staple in the diet of the Aztecs, but it was banned when the conquistadors arrived in South America because, aside from eating it, it was also used in some of their religious activities. But, in recent years, it has been rediscovered, and they are looking at amaranth for feeding poultry. But there are about 60 different species of amaranth. Some grow spinach-like leaves, which are eaten as a salad, some for ornamental or decorative purposes, and some for the small seeds that they produce. The seeds are usually high in protein for a legume, with a well-balanced amino acid profile, high in lysine and tryptophan. Nearly twice the amount of lysine that's in wheat and 3 times the amount of lysine that's in corn. They are also high in methionine being that one of the first limiting amino acids in poultry, corn, soy diets, but they're low in leucine. So lysine levels are similar to that found in milk. They also contain squalene, which is usually found in the liver of deep sea fish and other marine species. Research has shown that dietary squalene might improve the reproductive performance of broiler breeder males. If you're doing artificial insemination in the, should be, male MALE diet with squalene, it increased the serum testosterone level and level of serum collection value, but had no effect on the egg fertility rate when you were using artificial insemination. If they were naturally mating, however, supplementation of male diets with squalene did increase the overall fertility rate for the flock. The fat content is high in the unsaturated fatty acids, especially the linoleic acid, which is needed for egg production. Again, you have to watch out for going rancid if it's stored too long. But, they also contain anti-nutritional factors. They have the saponins, the trypsin inhibitors, which is a protein enzyme, phytate. It's higher than that of rice and millet, but lower than corn and wheat, and similar to what you see in some of the sorghums and millets. And they do have some tannins. Raw amaranth can be included in meat chicken diets below 20%, but if you heat it to destroy some of the anti-nutritional factors, you can increase that to a 40% diet. Treated amaranth can also be included in diets of laying hens up to 40% without adversely affecting poultry performance. Dried amaranth leaves can also be fed to chickens. I often say this when I go overseas to work. The leaves are relatively high in protein, about 25%, and a lot of it is methionine. The leaves must be dried before they can be used to destroy any heat liable anti-nutritional factors that might be present. Quinoa, another one of those pseudo cereals that has been discovered. They're not really related to cereals. They're more related to beets and spinach. grown mainly in cool mountainous regions because high ambient temperatures of around 90 to 95 degrees Fahrenheit cause sterility of the pollen, so it can't grow. It's high in protein, relatively high in protein, 11 to 18%. Remember, it's being added as an energy source. It's an excellent amino acid profile, high in both lysine and methionine, so it complements some of the other diets, as well as to legumes. So corn soy diets could be complemented with quinoa. Also has higher levels of energy, calcium, phosphorus, iron, and B vitamins than corn, barley, wheat, and oats. Seeds have a coating of a bitter tasting saponin. It's very low, but it's enough to put off birds. It reduces the need for bird protection during production, but if the birds don't want to eat it, neither will poultry. Saponins are in the outer layer of the seed hull and can be removed by washing. Research has shown that quinoa should not exceed 15% of the content of the poultry diet. So those are the alternative grains. And so are there any questions? Went through it quite quickly. And as I said, I can't make, broad recommendations on the use of wheat, barley, oats, quinoa, amaranth. It all depends on the variety that you are growing and how you grow it and where you grow it. Yes, this is being recorded and it will be available on our YouTube page. And if you go to our website of poultry.extension.org, under webinars, you will find it when it goes up there, and you will find under past webinars, you will find all the recordings from past webinars. I don't think that the ornamental amaranths produce much grain, so I don't think they would be used for feed. Ideas for research with a view to evaluating sources that do not exist in our country and introducing them into livestock feed in general. I'm going to request the PDF version as a reminder. I'm pleased to see that sorghum is emerging as an alternative. White sorghum is especially recommended because of its almost zero tannin compared to the red sorghum or brown sorghum. We have a variety of sorghum that we call whatever that is, which is very popular at the moment because it can be used to feed livestock. When I was in Kenya working with using different sorghum levels, some of the more native ones, they had 13% tannins. I mean, you can't. And then of course the literature says people prefer low tannins to eat, as a cereal. But with the farmers that I talked to, they preferred the high levels of tannins because it stayed in the gut longer. And so they could go out to the field and work all day without getting hungry, having to go back to the house. So don't always believe what you read on the internet. Did I miss anything? Don't see any questions, nothing on the Q&A box. So I'd say next month, the first Tuesday of the month will be alternative protein sources for poultry diets, not necessarily plant-based. There are other protein sources that are not plant-based. So I hope to see you then. As I said, this recording will probably be up first thing tomorrow. If not later tonight, depends on when they send me the recording and when I can edit it. So thank you very much for coming, and I hope I will see you next month. Whoops, messages. Okay, you're most welcome.